Okay, so this is 200, right? First programming class. How many of you have ever programmed before? Nah, I'm not counting what you did in 150. That's, okay, so 2.25 people, that's fine. So I assume in here that you've never had any programming, so we start from scratch. Having said that, programming is hard, okay? You have to approach the class a little different than you typically approach your other classes from the perspective of you can't cram for a test or something in here. You can't like sit up for 5 hours the night before and memorize a bunch of crap and come in and expect to get any more than a 0 on a test because it's not memorization. It's kind of a skill set. How many of you play a sport or an instrument of some type? Or something along those lines. Most of us in here have something that we can. Programming is much more like that, right? Where you could, if you watch an NBA game on TV, you're not ready to go into the NBA. Okay, you have an academic knowledge of something, but you're not going to be able to necessarily do it yourself. It's going to take lots of reps, lots of practice. Most of you are going to suck at programming for a while before it finally clicks and you get better at it. That's okay. That's par for the course. I expect that. All right, but if you don't put in the time in the homework, I mean, what's going to happen is early on, your homework assignments are going to take you longer than you think they should. And they're going to be very easy assignments. And in, a year, you'll go back and look at that assignment and say, that would only take me a minute to do. But at first, you're going to make so many mistakes, and the thing's going to constantly be yelling at you that you're just going to be frustrated, pulling your hair out, blah, blah, blah. That's why I don't have any hair left. Okay. I've made those mistakes for years and years and years and years. So I've been teaching programming for 18 years at the college level. So it's hard. Expect it. Expect to put in a lot of time. If you plan on kind of blowing this course off and, just skating through, giving it 45 minutes a week or something like that, grades are probably going to reflect it really badly. All right. So let's go through the class and I'll tell you some of the good news stuff. Syllabus is up on Blackboard. You can read through all this junk. This is me, Mike Littman. You can call me Dr. Littman if you want. You can call me Littman. I don't care. I'm not a formal person. In any case, that's my email address. This is my cell phone. Best way to reach me is email or text. Calling me is probably not a great, you can call and leave a message, but I probably won't pick up. I only pick up for my wife and my mom. But I do respond to texts. Feel free to text me up until maybe 1 in the morning, something like that. So I'm always happy to help. Don't wait until, 40 minutes before your homework's due to come in and ask for help. Let's see, blah, blah, blah. Normal stock stuff. Textbook for the class. And you won't need to get this right away. Because we probably are not going to start using it until maybe week 3-ish, something like that. You can certainly get it right away and start looking through it, but I use an online textbook from a company called Zybooks. So you go to zybooks.com, there's a book code, book's like $50 or something like that, but it's an interactive textbook. So really helps you with those kind of the drill type things, as opposed to just reading a book and, forgetting everything you just read. So in any case, sometime between now and week 2 or 3, go ahead and subscribe to this book. You'll have access to it for the duration of the semester, and that will help you out a lot. Blah, blah, blah. Here's like the breakdown of the crap in the class. Go down here, how grades work. Homework assignments are going to be 60% of your grade. I do give pop quizzes. A pop quiz will count as a homework assignment. Okay, so, and those can come at any point in time. Typically, I give pop quizzes. Well, sometimes I'll warn you about them the class before, like, hey, there's a pretty good chance we'll have a quiz next class. Sometimes if there's really crappy attendance someday, I'll give a pop quiz. There's really, really, really crappy attendance. Sometimes I'll just pass a piece of paper around and give everybody a free homework assignment and everybody who wasn't here a free 0. So it's great value, great value. Attendance is important. You're all adults. If you have something better to do than come to class, that's fine. I don't care. But you're risking a quiz, which is translated into a homework assignment, which is translated into 60% of your grade. I get paid either way. All right. 2 exams, a midterm, and a final, each worth 20% of your grade. Now here's the good news. Many of you, if you don't, you don't put the time in for the programming stuff, or just hasn't clicked yet, many of you are going to do very poorly on the midterm. Some of you will do well, but some of you might not live up to your standards on the midterm. I do have a policy that if you do better on the final exam than you did in the midterm, I'll replace your midterm grade, midterm exam grade with whatever you got in the final. All right, so midterm is a checkup, if you will, but if you bomb it, you're not completely screwed. I don't think one bad day should translate into a bad final grade. Now, something else that's good. So typically homework assignments, it's more about time and completion than, perfection. So I'm not going through your homework assignments necessarily. If you make a small little error on your homework assignments, you're probably not going to lose very many points, if any points. I have and actually I don't think I put it up yet, but I have something that I call the self-assessment. So because one thing you run into specifically with programming is sometimes you might spend 10 hours on something and have almost nothing to show for it, which becomes problematic. Because then you're handing in an empty sheet with tears on it, and I look at it and say, you've done nothing, that's a 0, when there was actually 10 hours of effort put in. So what the self-assessment does is it gives you a couple of opportunities to, well, one opportunity to plead, but it tells me, based on your effort, what you think you deserve in this homework. Based on what you actually submitted, what you deserve in this homework. And then the most important part, because those 2 parts are more just I want to see what you perceive you think you deserve. But the third part is I want you to explain to me what was hard, what did you struggle with, how did you try to overcome that, blah, blah, blah. Because that's going to allow me to give you partial credit, even when you've given me very little to look at, something like that. All right? So every assignment you turn in, every programming assignment you turn in will require that self-assessment. I'll put that up after class. I forgot to link it. So that's some good news. Other good news is every week there's going to be a Bible homework assignment. And the way that works is I'll give you a chapter to read from the Bible. Shouldn't take you more than a couple of minutes, not a real long chapter or anything like that. And then you just have to write 1 or 2 paragraphs explaining how it relates to computer science or your major. Some of them will be loosely related, but it's forcing you to read something and respond to it. That's a homework assignment. So definitely do all those. It'll help boost your homework grade. Make sense? All right. So first one's already up. It's due by midnight on Friday. So you can see that on Blackboard. All right. Questions about anything at this point? All right. So, in any case, the syllabus is up there. A couple of things that we use. There's also a second assignment up right now, which is our Slack homework. How many of you have ever used Slack before? All right, a couple of you. So the department, well, based on the number of hands, I assume you did not use it in your 150 class. So the department has our own Slack channel. You see in here we have a Slack group for every single one of our classes, and then a lot of our hackathons are advertised on here, and all sorts of junk like that. So in any case, for your other first homework assignment, and this one is due on Wednesday, go to cuwcs.slack.com, create an account with your Concordia email address, and get into the CSC200 chat group, and give me your name and what you did over break, just some stupid thing like that. Proving you have access to it. I will make announcements on Slack. The department makes announcements on Slack for internships, things like that. So you want to make sure you have Slack on all your devices. There's an app for iPhone, there's an app for Android, there's a native app for Mac, there's a native app for Windows, and there's a web-based thing. They all have push notifications, so I would encourage you to turn on push notifications for at least the CSC200 class. So if I send out an announcement where an update on a homework assignment, something like that, you get that sooner rather than later. Sometimes I test the Slack usage by giving you some sort of like keyword or something that's going to relate to the quiz that we're going to have the next day. So it should be an easy quiz if you've only received your message from Slack. So no excuse for not having Slack. All right? It's not even something you necessarily need to make a point check as long as you turn on the push notifications, you'll get it just like you got a text message. Okay? And you're not going to be inundated with stuff unless you maybe put push notifications up for general. But if you put it just for the class, there's only really, some relatively low amount of information that comes across there. I do also encourage you, I'll get to you in a second, but I do also encourage you to use Slack for asking questions on homework, because if you have the question, chances are somebody else has it as well. I'm usually pretty quick at replying, but maybe one of your classmates will reply as well. Help everybody else out. Something you will find beneficial in this class probably is to create some study groups, work on homework together with 3 or 4 other people. I don't care. I'm not going to be sitting there looking for, whether you copied off the person next to you, because at the end of the day, my job is to give you a grade based on how well you've mastered the material. So the thing I'd warn you against is don't get into a study group where you're the person mooching off everybody else. You're not actually learning anything. I'll find out on the exams, and that's 40% of your grade. Makes sense? So study groups, try to learn the stuff. If you're going to learn so much from class, maybe you don't like the way I'm explaining it. Maybe working with some other people and kind of struggling with folks at your own level will help you, learn the stuff better, whatever. So definitely take advantage of Slack for communication, asking questions, all that jazz. Go ahead.
Do you want us to create a new account in relation to our Concordia emails? Slack, or do you mind if we use an older personal account?
Well, you can use your older personal account, but I think you will need your Concordia username and password for to get into the CUWCS group, because the group won't let you join unless you create an account with your. I mean, I know what you mean. Like on my Slack, I have multiple groups that I'm in up here.
I have a personal Slack on a different email that's not related to Concordia.
Yeah. Well, so if I go in here and I say join one, it'll tell you to put in your, cuwcs.slack.com. And when you hit continue, I think it's going to probably ask you to put in your username and password from Concordia. So it'll all link under the same account, but I think there's an account per Slack channel. But anyway, you cut it, get in there. I don't care if you've gotten in with your cuw.edu email, but I think that's the only way to get in because of the way we have it set up. All right. Any questions about that? All right. So everybody should be on Slack by Wednesday. So we should be good to go there. So a couple other things. So let me just give you some highlights here. If you once you get into the Zybooks site, you won't have all this stuff. You'll just have the 200 Foundations of Programming. All right, so we actually approach programming in here from two different sides, and I'm going to, like I mentioned, you're not really going to need this book until maybe week 2 or 3. I'll give you, a heads up beforehand. So the programming language we're going to use in here ultimately is a language called Python. Okay, but before we get up to that, we're going to be talking a lot about programming in general and a bunch of other stuff that we'll start talking about here in a few minutes. But we're also going to, and this is the first time I'm using it, so we'll see how it works out. But we're going to use this platform called Mendix. What Mendix is, it's what's called a low-code programming environment. And you can actually create mobile apps and web applications using Mendix with very little, if any, programming. My attempt this semester is a challenge with programming typically is that we need to get your mind thinking in a different way, and then at the same time, you're also learning this weird-looking language. So you kind of have 2 challenges you're fighting at the same time. So I'm attempting to introduce you to less scary syntax early on, while still learning the programming stuff. And then once you kind of have the programming mindset switched over, then you can move over to some syntax. Maybe we'll kind of do a hybrid for a little bit, do some Python and some Mendix stuff until finally the Mendix stuff feels boring because it's mostly drag and drop and things like that. And then you can get scared by the programming once you already know more programming stuff. All right, so we'll see how that goes. I'll probably be asking you for some feedback from that, but Mendix is free. And it's a pretty cool platform, so we'll talk more about that when we get there. But before we get there, we have some other stuff to talk about. All right. Also here on the Blackboard, I have a link to our slides. So I'll keep slides in Keynote, and this link will take you right to a web page that has live updates for our slides. So you'll be able to get the current version at any point in time just following that link. I also record all of my classes. I've been told it's a good way to put yourself to sleep at night. Another thing you'll find is I'm far, far funnier than anybody teacher you had for 150. Yeah, I get off topic often. Okay, so in any case, I record all my lectures. I put them on YouTube because Panopto doesn't work. So I know some of your other teachers might use Panopto. I think it's a piece of crap. So I don't use that. So here's the link to the playlist I have up on YouTube. And any of the other classes I teach are all up there as well. So if you want to preview any of the future classes you'll have to take, you can see all those as well. Let's see, anything else on here? I think that's about it. Okay. So let's start talking about programming. What is it? So based on your preconceived notions or things you've done before or what they fed you in 150, what is computer programming? What do we think? Telling a computer what to do. Love it. Doesn't have to be any more complicated than that. So one thing I try to advocate is, and this happens in a lot of technology type classes, is we try to come up with really techno difficult sounding answers to things, right? I try to dumb it down to something that's meaningful to all people. All right, so we are going to approach programming in that light. So this is telling a computer what to do. All right, so now the next question is, how do we accomplish that? All right, so what is a computer? When we think about computers, what does that mean to you? All right, so it's a machine. What are the characteristics of a computer? What makes a computer different than us? Okay, doesn't think independently.
Sort of like a tool that we use to help us create and solve problems.
Okay, and how does that tool work?
I guess we would use it to create other tools to make life easier for us. I guess is one way to put it. Like creating an app that would keep track of our time instead of like manually doing it.
Okay, and how would you create that app?
Programming,
okay. Or using existing tools that are already out there, right? Yeah, so some of you in here are going to be computer science majors and some of you are IT majors, right? How many of you are IT majors? I assume the rest are computer science? Okay, so somewhat close to half, maybe a little bit more computer science than IT. What's the difference between IT and computer science? Go ahead.
IT is using the tools that are already made, and computer science is creating new tools. So like IT is implementing, and computer science is creating.
Okay. Yeah, I mean, I think that's mostly true. I think to take it even a little farther, I say that they're different sides of the same coin. Okay, computer science is about 75%, as you said, creation. We're making new stuff, programming stuff, things like that. 25%, we're using things that already exist. IT is about 75% of the time you're using things that already exist. 25% of the time you are creating new things. An important caveat there is a lot of people in IT think that IT means no programming. I could actually make the argument the programming you'll run into in IT is more difficult than the programming you'll run into in computer science. Now, why is that? If 75% of your job is creation, is programming, as a computer science person might be, don't you think that we've created a whole bunch of tools that make programming easier? We have all sorts of nice, for writing iPhone apps, you drag buttons around and all sorts of stuff like this. It makes your life a lot easier. You have these tools that make you not have to remember every little stupid thing. As an IT person, the types of software you're writing are different types of software. They're not necessarily business applications or video games. A lot of times they're things that allow you to do your job easier. Automated backups, account creation, account deletion, things like this. So instead of having this nice piece of software that's been built specifically to make your life as a programmer better. You're using some old style Unix text editor. It's different that you have to go through some sort of tutorial just to learn how to edit the text because you don't have Notepad, okay, available to you on Unix. And instead of having a computer sitting here right in front of you with a nice graphic user interface, no, you're remoted into some router that's sitting under the floorboards halfway across campus. All right, and instead of crawling up there, you're sitting there with a little SSH session or something like a terminal. Your whole screen looks like this. And you're actually going in. You're typing some stuff in here. No mouse things, right quick. So you're actually giving commands to a text editor. That's your life as a programmer, as an IT person. Now, good news is you're only doing that 25% of the time. Okay, but the punchline here is that it's an incorrect thought process to say that IT is not programming. Right? IT is very much programming. You're just using programming less often. Okay, but when you do programming, it's probably more complicated than the computer science person who spends all their time doing programming. And even the 25% of the time that we're using somebody else's code, or somebody else's tool. A lot of times it's somebody else's programming language that they've already or programming widget that they've already created a nice little way for you to talk directly to it. They even make that convenient. All right, so kind of keep that in mind as you go through here. I know some people, when they first go into a technology field, it's not uncommon for us to have juniors and seniors here who view IT as the way to avoid programming. Okay, and I'm going to sit across from some of you in several years, and you're going to still think that. And then you're going to get into industry, and you're going to be surprised when you're that one person who can't write any code, and then you end up having to do the stupid jobs like fixing printers, something like that. All right, so. Programming, what is programming telling a computer what to do? How do computers work? I asked you how computers differentiate themselves from people. You said they don't think on their own. How do you make them do things? You write programs, you use software that's already existed, things like that. But when we write programs, we want to think, what does it mean to be a programmer? And the example I usually use is, how many of you came to class today and didn't bump into any walls? Usually get the couple of smartasses that say, "Oh yeah." Okay. How often, when you're walking down the halls of campus, do you see people not even paying attention what's in front of them? They're texting and stuff while they're walking. Often, right? But they still don't hit people. They still don't bump into walls. How? How do you walk? Let's just start with that. Well, actually, how did you all avoid the walls when you came to class today? Did you just get lucky? Like every now and then, the moons align. Practice. Okay, what kind of practice? Was this like, did you really focus? Like, okay, I've been hitting a lot of walls.
Mostly
Okay.
walking is muscle memory.
Muscle memory, okay. Now you're looking at your cell phone, right? While you're walking down the hall, but you're still missing the walls. Are you kind of glancing up?
Like half a second.
Same thing with driving. When you're driving,
Oh,
when you first start driving, you have to make those. You really have to focus. Like, okay, I'm supposed to check that mirror. Then I check this mirror. Then I check this mirror. Once you've been driving for a while, do you start recognizing that you're glancing at those mirrors without even thinking about it? It becomes second nature to you, right? Now, when you're walking down the hall, avoiding all the other people who aren't paying attention either, okay, you got these folks who are all texting and they're just passing each other. Okay, when you're doing that, you're probably glancing up. What things are you looking for?
Incoming objects?
Feet, incoming objects. Is it more of a trajectory type thing? You kind of glance up and just see, within the next 4 or 5 seconds, will I collide with something? And you just kind of put yourself on that path and hope that you're good for 3 or 4 seconds, right? Okay. And then, you glance up again to make sure the next 3 or 4 seconds are safe, whatever it is. Same thing when you're texting and driving. Except the problem with texting and driving is you're going faster. So that 3 or 4 seconds you're covering. So don't do that. All right, so that's just looking where you're going. Now, let's say that you're about to bump into something. You see that, if I don't make some sort of adjustment, in 4 seconds, I'm going to smash into a wall. What do you do? What are your options for adjustments? Go ahead.
Stop or change direction.
Okay, well, we hope that you're not going to do a lot of stopping. That would tick people off, especially between classes. You have the crowded halls. You just go stop and you go through this huge checklist of decision making. But change directions probably makes some sense, and there's probably a little mini pause in your head, right? Whether you actually came to a complete stop or not. Okay. Now, when you change directions, what are you actually doing? How do you change directions?
Send a signal. Your brain sends signals to alter its course.
Oh, okay. Do you have a list of those signals you can send?
No, I don't.
All of you are changing directions sometimes, right? Do you have some sort of cheat sheet? Like, how do you go left? Oh, you just turn. It just happens. You just magic. You think left and you go left.
With your feet. You rotate your feet. Go left.
Okay. So what's involved to make that? Think if you're horseback riding, you want the horse to go left. What do? You yank on that horse's neck, and he starts going. Well, actually, in my experience, typically is the horses don't want to carry my kind of weight, so they sit down or try to throw me off. True story. So what's involved?
Constantly sending signals back and forth to the brain, muscles, nerves.
Well, how many muscles? How many muscles are involved in turning left?
A lot.
A lot. Okay, that's the correct answer. A lot of muscles. Okay, so you all came down the hall today, didn't bump into anybody, were bobbing and weaving, not even paying attention around of you. And most of you in here, you probably have a couple who have had an anatomy class or something like that, but most of you in here couldn't even tell me within 50 how many muscles we have in the body, right? You couldn't name more than 4. All right. Yet you're in full control of those things. Wow. So even the most untalented of you got to class today knowing almost nothing about how your body works, but somehow you were able to drive that car. Somehow you were able to get here without banging into anything. Right? Well, it still is work. Subconscious is even more impressive. That means it's so simple for you that you don't even have to think about it. Okay? You have these hundreds of muscles that, even to make that, he was like, oh, just turn your hips and you're good. Turn your hips, you're good. Your shoulders just come around with it. Sometimes you just lean your weight. Well, what does that mean? What does it mean to lean your weight? Basically, what is walking? Walking is you're constantly catching yourself from falling over. But you're paying attention to your phone. How do you do this? You're all amazing. You watch one of those, like 3-week-old babies that can't even hold their own head up. That was you. Hey, now you're this. Where walking is such a trivial task that you don't even think about it, that you can't even tell me how you do it. Yet you do it every single day. That's the problem. This is why becoming a computer programmer is difficult. Human beings are so good at solving problems that we find it very difficult to articulate how we solve problems. All right? When you chose to go into computer science, how many of you were going to definitely have a couple at least? How many of you went into computer science because you're a video game player and I want to write games? You got like one guy, like 8 of you want to raise your hand. Okay, well, I'm going to write games. Okay, so what's your favorite game? NBA 2K. Okay, so that game has pretty good graphics, right? Lots of stuff going on. Do you think that game's probably hard to write? I think there's a lot of really complex stuff. Okay, which do you think is harder? Walking down the hall while texting on your phone and not bumping into walls, or writing that video game? Not even close. Writing that video game is so trivial compared to walking down the hall that it's not even funny.
Is that because walking takes months to develop?
More than months.
Months to years to develop.
I mean, really, the evidence here is that we're so good at solving problems that we can't articulate it, so that the best we can do, if we assume that this NBA 2K video game, pick your favorite video game with crazy graphics and explosions or whatever, that's the most complex that we can do. And if walking is a 10, NBA 2K is a 0.1. It's so much more trivial than walking, but that's the best we can do as a programmer. Because we have such a struggle articulating how we solve problems. We can't slow our brain down. We can't articulate each little tiny muscle, each signal we're sending to our brain. Fire this muscle, fire this muscle, fire this muscle. We just got the guy here who says, swing your hips. Hope for the best. Or I take the approach where I take up half the hall, so I just kind of go like this, and everybody else just has to move. Right? That's what my wife does. She just follows. I have a pocket wife. We don't have to buy a second airplane ticket. So she just follows behind me, and the crowd parts. I just put myself on a trajectory and just pretend like I don't notice anybody else. I'm also very tall, so I could just look above them, and really, sometimes I don't see them. I run into signs pretty often, too.
That's how complex this walk is. Try being an Olympic gymnast. How many times they got a constant?
Yeah, I keep thinking I should become an Olympic gymnast. The issue is I'm actually too short. Yeah, if I could get to like 14, 15 feet tall, I'd be about average weight.
I'm thinking it takes all the distance to walk. You got to constantly do it fast.
I know.
While under stress.
People are amazing. You're right. We're so amazing. We can do things that we don't even know how we do it. We just do it. You pick one of these guys. They're like a skateboarder. They're doing these flips off of the arm rails and crap. How do you do that? We cannot solve problems at that level of complexity through programming yet. We have to solve little tiny baby problems, simple, trivial problems like NBA 2K, like Battlefield, like Microsoft Word. Software applications that are in our mind, we think, oh, those must be difficult to write. Whoever wrote those must be geniuses, right? Yet that's the best we can do because we suck so bad at articulating how we solve problems that we can't get beyond that. All right, so we're starting off with this idea that we're already really good at solving problems, right? Everybody's happy with that. We all got to class without bumping into any walls. We all kind of accept that was, pretty complex, except the swing your hips guy. It's basically just a dance down the hall, right? See, you've opened yourself up to this one.
I'm just taking it.
All right. But at the same time, we've accepted that we're really not very good at explaining to somebody else how we solve those problems, right? We've already seen an immediate weakness for something that isn't even worth our full attention. Do you suspect there's we probably across the board aren't real great at breaking problems down to those little tiny steps and explaining them to somebody else? Fair assessment? We can't talk about walking, which we're texting during. Other things are going to be difficult too. All right, so let's think about how we solve problems as people. So I like to break it down into 3 pieces. Now, we can make an argument that, there's other pieces to this, but like I said earlier, I like to kind of dumb things down and look at it at kind of a high level. So we all use our memory, right? How many of you in here don't know your own name? At least we didn't get any hands for that one. Okay. You know your phone number, you know your address. Those are things you're remembering, right? What's this? Yeah, I mean, we have our limitations, right? How many of you memorized the first book you ever read? Yeah, that one guy in here with the eidetic memory. I just can't stop. So we all have memory because we have to remember things, right? Is that part? What if you couldn't remember stuff? They make jokes about it in movies. The person with a short-term memory, right? Like, hi, I'm Mike, and then 2 seconds later, it's like, oh, hey, I'm Mike. They just meet him for the first time, and it's funny in a movie. But think about how debilitating it would be if you didn't have the capability of remembering something. I mean, some of you might perceive that Mike, I don't have that great of a memory. Or some of you might think, I have a really good memory. But even those of you with really crappy memories, you still rely on that memory. Maybe if you didn't even know what your name was, then, you know, the cops are going to pick you up. They don't know where you are, who you are, where you're from, blah, blah, blah. You don't know where you're going. You had to remember that you had to get to this classroom today. Even if you had to check 5 or 6 times when you got near the room, like, is this the room? You still had to remember something. You had to remember that you were going somewhere. So if you didn't have your memory to fall back on, if you didn't have that as part of your problem-solving process, you would be pretty debilitated, right? Memory is important. All right. What else do we do? We ask a lot of questions. So earlier we were talking about going down the hall without bumping into walls and stuff like that, right? Now, even though, I mean, we've already covered that we're so good at doing that, it's not really worth our full attention. But do you suspect that as you're walking down the hall and as you're, you know, just for a couple of short seconds, you're glancing up to see if you're about to smash into anything, do you think you're probably asking some questions? Like, am I going to hit anything? Am I going to hit anything? Do I need to go left? Do I need to go right? Do I need to swing my hips? What do I need to do? Right? This could be going somewhere because there's a little funny story. He was one of our actually best computer science students we've had before. His name was Jordan Mather. He graduated several years ago, so most of you probably don't know him. But he sat right there, first day of 200. And I asked some question about, I don't know, some TV show or something like that. And he said he doesn't watch very much TV. So I assume no TV means no electricity must mean he's Amish. As a senior, his classmates didn't know what his name was. Everybody called him Amish. So it starts with the hip swinging thing. I don't know where it's going to go. That's what I'm saying. And now he works at Acuity up in Sheboygan, and they still call him Amish. But that one's way better. We had a football player years ago. This must have been a decade ago or something like that. Really, really good guy. And he was, short in stature, but pretty ripped. But not quite He-Man ripped, more She-Ra ripped. You know who She-Ra is, right?
Yeah, He-Man.
Is it sister? Whatever, yeah. The whole football team was calling this guy She-Ra. So every year, like on my birthday or whatever, he messages me saying, "Happy birthday, She-Ra." He actually got a really good job at Discovery Card, so he did well for himself. But yeah, sometimes these things just take on a life of their own. It's bad. So I don't know where this hip swinging thing's going to go. Kind of where I'm going with that. All right. So in any case, as we're walking down the hall, are we probably asking a lot of questions? Am I going to hit anything? Am I going to fall over? Am I going to trip? Am I going to do this, that, the next thing? Even though we don't recognize, we drive ourselves crazy, right? Even though we don't recognize we're asking all those questions, do we believe we probably are? We're probably constantly asking little micro questions in the back of our mind, and then making, based on what the answer to that question is, maybe making some decisions, doing something as it relates to it. All right, so that's another way we solve problems. We ask a lot of questions. We're also big fans of repetition. Big fans of repetition. So even the act of walking. We've already covered that we have trouble articulating how we're doing that, but at the same time, we see that there's kind of a repeating pattern to that. So under the hood, whatever the answer is to how do you walk, we're kind of repeating those steps over and over and over and over again. Same thing with how we breathe. I know these are innate abilities. You don't have to think about breathing, but it's the same pattern over and over and over again. Human beings work with repetition. We like to put things into situations of repetition. All right, so this is how we solve problems. What's a programming language?
Like Python, Java, JavaScript.
That's an example of them. What's a natural language? English, French, Spanish, German, Russian. These are natural languages. Well, what makes it? What's the purpose of a language?
Communication.
What?
It means we're interpreting person. So, well, with this laptop, this might mean something else.
Okay. So when I'm saying stuff to you in English, how do you know what I mean?
Because that's not English.
Okay, so there's semantics. There's things that when I say some words, those words have you kind of translate those words into some like semantic meaning in your head, right? So I can say the same phrase in 20 different natural languages, but it ultimately still has the same meaning, right? All right. So what's a programming language? With a go ahead.
Well, it's like a formal language that provides, like I said, like instructions, stuff, and communication, but an output for a computer.
Okay, a very technical answer.
Yeah.
Yeah, I mean, at its heart, you're right. But we want to keep it at a higher level than that initially. I mean, you're not wrong. I mean, that's the correct thing. With a natural language like English, who are you talking to in English? Go ahead.
Another person.
A person. So our target is a person with these natural languages, right? So these languages have been designed with our target in mind, right? So a person can read between the lines. A person takes more into consideration than just what you're saying, right? You look at facial expressions to kind of know whether you're being made fun of with hip swinging and that kind of stuff. You know, there's inflection. He's getting a bigger kick out of it. There's inflection. So humans, when we communicate, it's very complex, right? There's things that we're doing that go far beyond the exact words that are being said. With a programming language, who's the target? A computer. Okay. Now we're back to that question of how does a computer differentiate from us? How are we different than a computer? Because when I'm talking to you, we're the same thing, right? We're both people. And a really interesting way to kind of consider that, so in our grad program, I teach a lot of classes in our grad program, a majority of our students are non-American. A lot of them are from India, Saudi Arabia, Nigeria. Nigeria speaks English, but so let's take India, for example. It doesn't matter whether they're speaking English or they're speaking their native language, whether it's Hindi or Urdu or one of the other languages, their thought process is the same. When they're talking to a friend, they're saying, I want to communicate an idea to my friend. And they're going to choose a language in which to communicate. And the language they're going to choose, hopefully, is a language that they both understand, right? I mean, if somebody ran up to me and started spouting stuff off in French, that's not going to be very meaningful, right? Because I don't know French. Okay? I mean, there's many people who do, but I'm not one of them. Okay, so I speak English and bad English. A little bit of Spanish. I could order at Taco Bell. So punchline here is that not only do we need to pick a language, not only are our natural languages, built for human beings to talk to each other, we also have to pick a compatible language that both human beings are familiar with. When it comes to a programming language, these guys are built for a human to talk to a computer. Okay, so now we're crossing species. Significantly crossing species. We're going from living to nothing to non-living. How do we do that? Now we have to understand how does a computer work? So what's a programming language? Language for giving a computer instructions. So now we have to ask, what's a computer? What's a CPU? Central processing unit. What's that guy? So when you open up the computer, you got a bunch of parts in there, right? You got a hard drive. What's a hard drive for? Storing crap. Right? It's for storing crap, but it's long-term storage of crap. Okay? So like in your brain, don't we have we have those memories like, look, I saw a movie, there was a character in the movie, it's in there. We all have those things that are somewhere inside our brain. And with the right amount of alcohol and digging, it might come out, right? But that's long-term storage. What's memory? You got your computer has 4, 8, 16 gigabytes of memory. Usually it's smaller, right? Smaller amount of memory in your hard drive. You got the 2 terabyte hard drive, and then you have your 8 gigabytes of memory.
Your
Active memory, fast memory. Okay, that's probably where you're storing what your name is. When you wake up in the morning, you boot, right? You're loading all this crap in that you might need readily access to, like what's a hand. Okay, so you're kind of loading all those pieces of software that just allow you to function in your first hour of being awake. Okay, but you're probably not loading all this information about some TV show that you saw when you were 4. Okay, so in any case, that's our fast memory, remembering stuff that kind of needs to be at the tip of our tongue. What about the CPU? What's that guy for?
I think it's the interpreter for you and your computer.
Interpreter for you. Let's keep it in this metaphor of how we would work. What's our CPU as a human? Our brain. Okay. So far, everything we've been dealing with is how our brain works, right? Long-term memory, short-term memory. And now the CPU in general is what aspect of our brain?
Decision making.
Something along those lines, something like decision making. So if we were to dumb it down, it'd be hard for us to make a list because we've already decided human beings have a lot of talents that we take for granted, right? But we could probably make a pretty good list of things that we're capable of doing, right? If we were a toy, here's all of our features, right? You take your hand, we can move individual fingers, we can do different joints. We have all sorts of things we can do to the point, and some of them in and of themselves, is meaningless. It's like, okay, so my thumb does that. Who cares? That allows you to solve some other problems. If I do this with, if I'm going to pick something up and I just put my hand on top of it, unless I could do the whole, do the sticky stuff, right? Then you can probably pick it up. But otherwise, you need to do some other motions. Take some of those atomic attributes, those things that you can do, and you put enough of those little features together, and all of a sudden you can accomplish real tasks, right? So a CPU is a collection of, I like to think of it as magic tricks. That I'm just going to say computer, generalistically right now, knows how to do. Each magic trick might not seem like it does much. Just moving your thumb like this might not seem like it's really accomplishing any real thing. But when done in conjunction, can I spell that? Conjunction with other magic tricks, real problems are solved. That makes sense? That's what the CPU is. So what we'll do is we'll come back on Wednesday and we're going to pick up where we left off here and continue to kind of think about what a programming language needs to do for us, how they work. And ultimately, we're going to come to this conclusion that it doesn't matter what the programming language is. It doesn't matter if you speak English or German as long as you're talking to somebody who also understands those languages. It doesn't matter if you're programming in Python or C++ or Java. Programming is the skill set. The language you're using is just the words that are coming out. All right? So make sure for Wednesday you've completed the Slack Dealy Flippy thing. And then you can go ahead and start on the Bible homework. It's not due till midnight on Friday. Just a paragraph or two. So whenever you have a time to go ahead and read that, go ahead and read it and write your little paragraph. And I will see everybody on Wednesday.